Honors Algebra 2, Chapter 10, Section 1. We're going to solve simple counting problems, use the fundamental counting principle, and introduce permutations. So the counting principle is just saying if we have more than one event that we can figure out how many number of ways both events can occur by multiplying the number of ways each event can occur. And so an example of that is if I had like 5 shirts and 4 pairs of pants, I can make 5 times 4, 20 different outfits with those 2 items. And so counting principle is just you're going to multiply. So if I have different events, so event 1, event 2, the number of ways that both events can occur is by multiplying m1 times m2 if that is the number of ways e1 and e2 can occur. Some examples here. If you're buying a pizza and you have some choices here, you have 3 crusts, 4 different cheeses, 5 different meats, and 8 vegetables. How many different pizzas with 1 crust, 1 cheese, 1 meat, and 1 veggie could you actually create? And so you can choose one of the 3 crusts, one of the 4 cheeses, one of the 5 meats, and one of the 8 vegetable toppings. Multiply those together, and you would actually be using counting principles to figure out how many ways that can occur. You do that, you have 4 times 5, 20, 20 times 8, 160, 160 times 3 would be 480. Another example is we're looking at telephone numbers here. They all begin with 329, and then are followed by 4 digits. So how many different phone numbers are possible? So we have 329, that we know. We have 1, 2, 3, 4 different digits after. A digit is a number. It's a number between 0 and 9. So how many numbers actually is that? There's 10 possible numbers for this digit, 10 for this one, 10 for this one, and 10 for this one. So I can multiply those. So that's 10 to the 4th, or 10,000 different phone numbers. There's another part to this. Part B is if the numbers cannot be repeated. So if they cannot be repeated, that changes the problem a little bit. Now it's not 10 for all of these. Whatever number I use for the first digit, 10, I cannot use that number again for the second digit. So now I only have 9 possible digits to choose from. The third one is only 8, and the fourth one is only 7. So now if I multiply that together, that's only 5,040 different. So permutations is another way of counting. Permutations is an ordering of n different events such that one element is first, one is second, and so forth. And order matters. That's the big thing to know for permutations here, that order actually matters. And so an example here is if we have 8 different teams that are competing for like a baseball playoff position. We can take those 8 different teams and figure out how many different ways can those teams finish the competition. And so then we can take for first place. How many teams can be first? 8. There's 8 teams. How many teams can be second? 7 teams, because one of those teams is first. Third would be 6, and it keeps going down. 5, 4, 3, 2, 1. And so this would be a permutation of 8 different elements. And you get 40,320 different ways those 8 teams can place. Another example would be how many different ways can 3 of those baseball teams finish first, second, and third. So they're saying that if you have 3 teams, you know that they're going to be the top 3. How many ways can they finish first, second, and third? It would be 3 times 2 times 1, which is 6 ways that 3 teams can place. But a more interesting question is if I have 8 teams, how many ways can the teams place first, second, and third? Now we don't know who is going to be first, second, third, so we have to choose from the 8 teams. This is the more difficult. So this problem is a different one. We're going to look at it in a second. But first, let's go back to this 40,320. That was found using 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is called a factorial. A factorial, there are n factorial different ways n elements can be ordered. N factorial means n times n minus 1 times n minus 2 and that continues all the way down to 1. So I had 5 factorial, it would be 5 times 4 times 3 times 2 times 1. Now if you have some operations in it, like 3 plus 2 factorial, you have to take care of the factorial first. Order operations, if I had 3 plus 2 then factorial, you have to add first, so you still have to follow order operations. A permutation, or order matters, is another way of saying that is we're taking n elements that are taking r at a time. So if you have a group of n elements and we're going to take r at a time, how many different ways or orders could you create from that? So it's found using this formula, which is npr, which is equal to n factorial divided by n minus r factorial. And we can use this for the second example we talked about over here, about if we had 18s, how many ways could those 18s place first, second, and third? And to do that, we would want to do 8p3. So what this is saying is we have 18s, we're going to choose 3 of them. How many different orders can we create? Different orders of 3 from the 8. So that can be found by doing 8 factorial divided by 8 minus 3 factorial. So this is 8 factorial over 5 factorial. Now 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all divided by 5 factorial, which is 5 times 4 times 3 times 2 times 1. So these all reduce out, so you only get the 8 times 7 times 6, 336. So there are 336 ways that you can choose 3 from a group of 8, where order matters. Distinguishable permutations are a little different, where we're actually going to look at eliminating the repeats. So you look at the letters that spell my last name Londat. There are 6 letters. So 6 factorial is how many different ways I can arrange those where order matters. But if I switch these 2 O's, the order does not matter for those 2 O's in those 2 spots. So I can divide that by 2 factorial. And so that would be 6 times 5 times 4 times 3, 360 distinguishable permutations for those letters. You do the same thing with shapes. So if I take these shapes down here, these circles, we have 3 or 4 blue, a red, and 2 green. So I can find, we have 3, 6, 7 different circles. So 7 factorial is how many ways I can order those. But I need to take away the repeats. There are 3 blue, there are 2 green, the 1 red, but I don't need to include that because it's just a value of 1. So this is going to be 7 factorial divided by 3 factorial times 2 factorial. So this is sitting at 7 times 6 times 5 times 4, and the 3, 2, and 1 can reduce out with the 3, 2, and 1 in the denominator, over 2 factorial, which is 2. So 2 reduces out with the 4 to get 2. So the same thing as 7 times 6 times 5 times 2. I'm just doing some reducing, really, is all I'm doing. And you get 420 different ways you could order those circles. I'm going to call it good for 10-1, and we'll see you tomorrow.